Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's main meeting. So we have with us tonight the always outstanding Kathi Kellenberger, who's going to talk to us about modern T-SQL for better performance. Before we do that, there is one quick announcement, and that is that we have someone in the area, Winston-Salem area, so, the Triad, close, looking to get some assistance with a SQL Server 2008 setup, looking for someone to be able to work with them on a little bit of medical and financial data analysis types of issues and a bit of administration work. If you are interested in anything like that, hit me up and I'll put you in contact with the person who's looking to do this. So reach out to me, use whatever bat signals that you need to, and we can talk. That one announcement aside, I am now going to hand it straight over to Kathi, so please take it away.
Thank you so much. Hey, everybody. I'm Kathi Kellenberger, and I'm the editor of Simple Talk at Redgate and co-leader of the data platform WIT group with Mala. Whoops, went too fast there. And an instructor at a wonderful organization in St. Louis called LaunchCode. We provide free training and apprenticeships for folks who want to have tech careers, and we're changing people's lives and doing a lot of great things in St. Louis and some other places around the country. The most important thing to know about me is that I'm a lifelong learner and teacher. So the reason for this session is I noticed over the years as I was speaking at a lot of SQL Saturdays and other events, and a lot of times about windowing functions, that hardly anybody had heard of them. At least the people in the group, very few, maybe 25% of the people in the room had even heard of them before. So that kind of led to this session, just thinking about how a lot of times we get stuck in doing things the same way. And I really want to show people that, especially since 2012, and that's almost 10 years ago now, it seems crazy. But for the, we've got a lot of new functionality in T-SQL that folks may not know about. And these things might make their life easier. So what I'm going to talk about, I guess I've got an hour. I've got several scenarios, and I'm going to show you how to solve them, how newer functions, especially the window functions, make these easier to solve, and a lot of times perform much better. And depending on how much time I have left, I'm going to talk about some of the intelligent query processing features. Those are also near and dear to my heart because they are Microsoft's providing a way for some issues that we've had over time, or some anti-patterns to perform well without you making changes to code. So I'm also love the intelligent query processing features as well. So depending on how much time we have. So as I mentioned, we get stuck doing what we know works. And I've been in the same situation where I've needed to solve a problem, and maybe I know there's some other way to do it that I've heard about, but I just don't necessarily know how to do it. It feels like it's probably faster just to solve it the way we know. And, a lot of times, especially in the past, the pre-2012 days, cursors and loops were really prevalent for just solving queries. We hear a lot of times about developers or other folks, going through a loop to do updates. We just cringe when we think about that. But a lot of times you're doing cursors and loops to solve some problems that are really easy to write today. We could, like, for example, finding something from a different row, a value from a different row included, might do something with a self-join and be really proud of yourself for writing that one query. However, if you had used a cursor instead, it actually would have been faster. Other anti-patterns like scalar UDFs. I have done some consulting at dev shops where they don't necessarily even have a DBA on staff, or in the whole company. Some of the smaller companies I've done work for, and I've seen UDFs, nested UDFs, multiple layers deep, and a UDF that found the same value. It didn't really have any parameters from the query. It was just a UDF, and things like that could have been, value could have been saved in a variable and that used in the query. I've seen things like that. I had one customer that had used so many UDFs that we were able to get a process. I mean, we shaved an hour off of a process. It wasn't all one query, but it was a process that was taking 1 to 2 hours to run. We were able to get it with a little bit of index tuning and unwinding all these UDFs. We were able to get it down in less than a minute. And that was on, I think the total data was about 4 terabytes that they were working on. So there's a lot of patterns out there. For some people just don't know about what's available or know what the best practice is. So the first problem I want to talk to you about is the stock market problem. And I have to tell you a little story about that. I was working at Pragmatic Works at the time, and I was at a customer site, and I was an ETL developer on that project. Really fun project for me. And the DBA there came to me and said, I have this process that I pull data from the stock market every night, and then I need a way to compare the closing price of a stock from one day to the next. I'm sure you can help me figure this out. And so I did. And a few months later, one of the junior consultants that I was mentoring at Pragmatic Works came to me and said, Kathy, I have this data that I pull from the stock market every night. I'm loading it into SQL Server tables, and I'm trying to write a query to compare one closing price to the previous closing price. And he had this really crazy query that was like multiple layers of, multiple nested subqueries. I think it might have worked, but it was just like really, really slow. So this is an absolute true story. I could not make this up, that both people needed the same help. And so this is kind of what the data looked like, and I'll show you what I showed them in a minute. I made up some fake data. Fake ticker symbol, fake prices, dates are real, haha. But this is what the data might look like. If I could take the close price of one day and pull it forward into the next row, I could calculate that change, okay? So let's take a look at, I'm going to move that over here. Take a look at how to solve this. And I got to find, there it is right there. I am going to use a table called stock history that's got almost 700,000 rows in it, and it looks just like that data that I showed you a minute ago. Every ticker symbol, made up ticker symbol, has a row, and for each day, and then you can see that we have multiple days. So there's a lot of data there. So how can I do that? So if I'm first trying to solve this query, I might have some ideas on how to solve it. So one thing I might do is write a query like this. If you've done this before, you can probably see the mistake that I've had. This actually creates kind of like a Cartesian product, because I'm not getting back just the previous price. I'm getting back the previous price over and over and over and over and over. Because I can't, if I add a top one, that doesn't help either, because then I just get back one row, just absolutely one row, not the whole thing. So that doesn't work. And I let it run for 19 seconds, and it had already come back with over 1 million rows, which it should only come back with about 700,000. So it kind of created like a Cartesian product there. I guess probably not a full Cartesian product, but very, very close to one. So I could also create a temp table and write a cursor to populate this. I could also do this. Now this is not, I'm not going to run it because it does take a long time. A process like this might be pretty quick, but it's going to scale, you know, like just a diagonal line. It's just going to scale like that. If you have twice the data, it's going to take twice as long. But earlier today, I think I let it run 1 minute. Previous time when I did this, I let it run 2, but my computer was like making that fan noise, like I'm suffering. So, you know, you can see that it does work. However, only 1,600 rows were processed. The whole thing wasn't processed. So what about apply? It was introduced in 2005, and I've heard so many people sing the praises of apply like it's the answer to everything. So for apply, what I've got here is I want in my apply subquery here, I want to find the top one row that's the same ticker symbol, but less than the trade date on the outside. And I'm only going to run it with just 4 symbols. And there's a reason for that. It's because this takes forever to run. It takes about 40 seconds to run. This time it took 5 seconds, but I only did it on 4 ticker symbols, and there's a lot more than that. So previously it had taken 40 seconds to run the whole thing. So I've tried a lot of different things so far, but the best solution for this particular problem is to use my favorite function, lag. So when I use lag, all I have to do is use the function lag, specify what I want. If I want to go back more than 1 row, I can do that, use that as a parameter. If I want to get rid of nulls, I can have a substitute value. And then the over clause. Okay, so I'm going to partition it by ticker symbol. I don't want ticker symbols to touch. I don't want them to be compared against each other. And I'm going to order it by trade date because that's how I want things lined up. I want to find the row from the previous trade date. And let me go ahead and run this. This is on all the rows. I'm not cheating here. It probably takes longer to populate. It's actually taking longer than I thought it would. I think it took about 5 seconds earlier today when I tried it. It takes a long time to populate the screen, but it is done. So it got the whole thing done in 11 seconds. If I was saving this in a temp table or, maybe just sending it off somewhere else besides populating, it would probably be even quicker. I want to show you while I'm looking at this, because I recently wrote an article about lag. And I started off, I wanted to write an article about comparing all the window functions, or a few of them, to other techniques. Well, so I started with lag. Again, it's my favorite function. So let me start with lag. And all I was working on was the just your normal join, your typical join out of AdventureWorks. And it was the same kind of thing. I was trying to find what I was trying to find was the days between orders. So the data kind of looked like that. And I went through a whole bunch of ways to solve it. I didn't even include views, which could have been used. So I went through all these different ways and ended up with a full-length article just on that. So if you're interested, take a look. When I got down to the bottom and compared all of the different methods, lag outperformed all of them. My next best was outer apply, but only if I pre-aggregated the data and saved pre-aggregated data in an index temp table. Then it was almost as fast as lag. Had a pretty high logical reads compared to it though. If I didn't use the index temp table, that outer apply was just It took 12 seconds. I guess it's over, I guess it depends on if 12 seconds is good enough or not. Depends on what you're doing, but it did take a really, really lot of I/O. So I thought that was interesting, example that I could just add to today's presentation. So I'm wondering if there are any questions at this point. And if you're interested in more about lag and lead, I've got a book out by A-Press on windowing functions, and there's tons of recordings of me talking about them. I have one on just an introduction on windowing functions, and then I also have a session that I do on performance, because there's just so much to talk about. So are there any questions? Again, this came out in 2012. I've had more than one person come up to me and say after a SQL Saturday session, and this was back, when 2012 was somewhat newer. Now I have the ammunition to go to my manager and tell them a reason we need to upgrade, or we've been trying to solve a query issue for months and I had no idea about lag. Now I can go to work on Monday and write a well-performing query. So again, my favorite function, if you ever need to grab something from another row, like the previous row or the next row, make sure you're looking at lag and lead. The next thing I want to talk about is the subscription problem. So many years ago, around 2008 and 2009, SQL Server Central had a contest called Speed Freakery. And what they did is they had a data set and they had a cursor solution. And these were some pretty difficult queries to write. And they had the gurus out there. Peter Larson was a guy who won most of these. And they were able to solve the queries in like milliseconds, okay? Probably took them longer than a millisecond to write them because they were very difficult. The problem was these queries that they wrote, they were like doing pivoting things, unpivoting things, doing weird things like quirky updates and just lots of techniques that the average person, and I consider myself one of those average people out there, really couldn't ever come up with themselves. I know I couldn't have. But what happened was Redgate approached me back then. And remember that Redgate owns SQL Server Central and did, I think, since 2008 or 2006. I can't remember exactly when, but Redgate approached me and said, we would love for you to write for Simple Talk. And how about writing some articles about the Speed Freakery contest? So I did, and this was one of my favorites, the subscription problem. So the subscription problems has some data that looks kind of like this. You have a registration number, and you have a date that they joined, and they could be any time in the month. You have a date that they ended their subscription, which also could be ended in the month. And what the goal is to figure out how many active subscriptions per month there are. Okay, and the data set was pretty big. I think it was like maybe 100,000 rows, not real big. Again, this is 2008, 2009. Also 2008, 2009 hardware, which is a lot different than what we have today. So the first thing that you've got to do is normalize on the month. So the winning solution, what he did was changed all the dates to the end of the month or the first of the month. I think he actually did the first of the month. I'm doing the end of the month for a reason, which I'll explain. And so this is what the data should look like. The month represented in some way, just one date per month, or you could even probably have year and month separated if you want. The number of people joined minus the number of people left, give you the current subscriptions. You take that total, then add the next people joined, the number of people left, you get that. So it's a running total problem, which is real easy to solve in today's world. So I can't see which slide's coming up next to make sure I'm ready to, yeah, I'm going to switch over to the demo.
Kathy, there is a question. Would you like to take it?
Oh, sure. Go ahead.
The person wants to know how would you do windowing function type of stuff before SQL Server 2012?
That's kind of what the whole session's about. So for example, all of these things that and it depends on which window function you're talking about, because they all do something different. So for example, all of the queries I had in the first example were legitimate ways to write the query and get the answer before 2012. Okay, so after 2012, I could write this query, which is easier to write and obviously performs much better. So I'm going to kind of show that as we go along with some of these examples. The next one especially. So, but yeah, that's really it. In 2012, I think that was just a gigantic year for SQL Server versions as far as T-SQL is concerned. That was a really important year. But probably one of the easiest on some of these things that are really tricky before 2012, cursors are just about as fast as anything else, which is really sad. Hate to say that, but back in the day they were.
That's how we did it.
That's how we solved these tricky things. I hate to admit that. I almost didn't include, in that article I showed you, I almost didn't include the cursor solution. But then whenever it ran in, I think, 2 seconds, I'm like, I'm including it. So the only thing, let me go back to that. Maybe I'll write some more articles on this with other functions now that this one turned out really well. If we look at this cursor solution, 2 seconds, I didn't even point that out before. So the cursor solution was faster than most of the other solutions. I could not get the logical reads. I found that if I left that toggle on for your automatic or your actual execution plan and left statistics IO on, the cursor solution took longer to run. If I turned those things off, it ran faster. So I have no idea how many logical reads it used. But yeah, that's how we solved a lot of things back in the day. All right, so let's look at the subscriptions or registrations. So the original problem, it was only 10,000 rows. I was thinking 100,000. It was only 10,000 rows. And the data looks like that. I went ahead and created a table of 1 million rows, just kind of random data. And since this is going to be aggregated down to the month, I ended up going back to like 1970 to make sure I had enough months and years in the data. So it would be really, really good data. And there are 1 million rows. 1 million rows there. If we look at the data, like the first step in really any of the solutions is to aggregate the values. So I can look at the number of registrations per month. So here I've just got a query that breaks down the year and month and the number of registrations. And I also have another query with the number of cancellations. Notice that there are many months that don't have any cancellations. I don't believe there's any months that don't have registrations in the data set. So you might have to do a little bit different on your join depending on what the rules are. But I made sure that we had months with no cancellations, that all the months have new subscriptions. So one way you might try to solve this, and I just did it on a subset of the data just to get it to run, is to do a self-join. So I just start with that similar query. Here I'm actually using cast to change this into a date, the first of the month, it looks like. I'm not sure what I'm doing, if it's the first of the month or the end of the month. And so I get the people joined, the people left, and then I do a self-join. I have another CTE, combined data. I should run this because I think it takes I'm not going to be able to run it. Even with the smaller amount of data, it's going to take a long time. But this would be the way, if you were pretty good with T-SQL, you could come up with to write this pre-2012. Okay, but it takes a long time to run. I'm already up to 20 seconds. This is even on a smaller amount of data. I'm just going to kill it. I don't want to waste time running that because it's like watching paint dry. So what if we use a cursor? I'm going to turn that off. This one actually runs pretty quickly. So I'm creating a temp table for subscriptions. I'm inserting in the number of subscriptions, and then I'm updating it with the cancellations. And then I have a cursor going through and figuring it out. So in those the original speed freakery, it's done already. So it took 3 seconds to run. So this is a really great example of when a cursor solution would have been the fastest compared to a self-join. Okay. And it does work. If you want to do some math in your head. This was the solution given to the people who entered the contest so that they could compare their results, make sure their data turned out correctly. So yeah, this would not be that hard to write, and it performed really well. Here's the original solution back in 2008 or 2009. It was Peter Larson. He created a temp table. He inserted into it, he used pivot. He inserted into it the number of people who left and joined. He used unpivot. And I look at that and I'm like, back then I did figure it out. I did spend time figuring it out. But I never could have come up with it myself. Then he did something that caused a storm in the SQL community. He did this thing called a Quirky update. So notice right here where he's got set at subscribers equals subscribers equal at subscribers plus people joined. So he's taking, it's a set-based query. Where is he putting that? Output. It's just like so hard to understand. I don't even see where he's inserting it. But this Quirky update caused a lot of controversy in the SQL community because it's not supported. And it was just like something I don't know, he might have just stumbled on it. And they said, you shouldn't be using that. That could stop working in the next service pack or whatever. But he won. And this query is now done. So there were 609 unique months in the time of my data, and it ran, let's see if I've got time IO here. low number of logical reads. And I didn't have time, but it's milliseconds. It's really, really fast. So I don't think most people could have come up with this or would have thought of doing things like he did, like this quirky update. And he's not really inserting, he's actually just doing this output clause. You know, it's just really different, but it was the fastest. And some other people who joined the contest also had some just really, really different things that most of us would not think of. So here's the modern solution. Again, I'm using common table expressions to do the pre-aggregation. I'm using EO month. I'll talk about that soon. I've got my new subscriptions, my cancellations, the outer query. I am doing a sum of the people joined minus the people left over order by date joined with what's called the frame. So in 2012, Microsoft gave us the ability to do moving averages, running totals, that type of thing, where you specify like a certain number of rows. This is really easy to write, and you get the same answer if you left this out, rows between unbounded preceding and current row. However, you'd lose the performance benefit. So this is the new way to do it. And it just runs, again, in under a second. So before 2012, really the only way to do this for the average person or even the pretty good person would be to write a cursor. If you were one of the top people in the world in T-SQL, then you, like Peter Larson is, then you might be able to come up with a crazy way to do it that no one else can understand. I once was sitting at a conference right in front of Itzhak Ben-Gon and Peter Larson, and I was just wishing that some of their brain power would, like, you know, reach kind of osmosis through the air and go into my brain. Nope, didn't work. Didn't work at all. But so are there any questions about what I just showed you or anything I've covered so far? So I said, be sure to add the frame. There are other frames besides this one, but to solve the problem I was trying to show here, that is the frame. And again, take a look at my performance. There's videos out there. I'm sure there are. Maybe under past TV. I know that it would at least be there. You know, on how to do this. All right, I'm going to move on to the next one. I talked about end of month very briefly, just saying that I got away from splitting the data part with cast and putting it back together. I use the end of month function. So in 2012, we also got a bunch of other functions that I like to call the easy functions, kind of like the easy button. They definitely make your life easier. They don't always perform as well. Some of them are equal. Some of them are worse. Sometimes it doesn't matter. Like one of my favorite is string split. People had, as soon as it came out, people were out there with articles and blog posts arguing about how it didn't perform that great. But if you've got, let's say you're doing reporting services and you have a commented limited list of 20 things going into a stored procedure for your report, using string split is a really easy, doesn't impact performance on 20 items. Now, if you're looking at thousands of items, maybe it would be a bad idea. But for just 20, it's easy and it's not going to hurt the performance. So let's take a look at the easy functions. Let's see, there we go, end of month. Go back up to the top. So here's some of the easy functions. Format, use with caution. It's really handy. I wouldn't use it on anything that is performance is critical on a large amount of data. But some of these aren't bad. So here's one way to take a data part and put it back together and get the end of the month. And that's just on sales order header table. And there's only, it ran fast, but there's not that many rows in that table. This only says 1,124 rows. That seems too small to me, unless we're, distinct. That's why there's that many distinct dates. Okay, but it starts out with about 30-some thousand rows. I like using Adam Mechanic's Thinking Big Adventure tables. He's got a table called Big Transaction History, and a lot of times I will take a subset of that, medium transaction history, small transaction history, tiny transaction history. This is my small transaction history table. And what I'm doing, just to kind of make sure that we aren't spending a lot of time populating the grid there, I'm throwing the rows into a temp table, and then I'm just going to select out the top 10. And I just want to show you, how long it takes to do it. It took 15 seconds, okay, to take that apart, put it back together. I'm going to drop clean buffers just to make sure that I'm starting with a clean slate. And I'm going to use the month function. Give it any month, it'll tell you the last day of the month. And I use that in the subscription problem. So I'm going to do the same thing on that same table of 7-point-something million rows. And I'm hoping that it doesn't take any longer. It took 6 seconds, and I already forgot how long the other one took, but it was comparable. So I didn't really get any degradation in performance on that large number of rows. But what if I tried it on the entire big transaction history table, which is 31 million rows? I wonder how well it would do. And I got to figure out how to keep talking while this is running. It won't take too long, though, I promise, unless something weird's going on in my laptop. You never know. I think it should stop any second now. No, it's still going. There it goes, 24 seconds. So it took 24 seconds to do 31 million rows. So it was 4 times. It really makes sense. It took 6 seconds to do the 25% of the table. If I multiply that by 4, I get 24. So it's just very linear in how it works. So I would say don't be afraid to use this function. Another function that I really love is concat. I teach a lot of beginning T-SQL people, and I have to teach them that you can't just concatenate things if there's nulls involved, and you can't just concatenate things if there are data types that are not compatible. But I'm really happy that I can show them the concat function, and the concat function takes care of data type conversions. Like in the second example, I can't, unless I would do a cast, I can't concatenate first name and middle name with the business entity ID, because I'd get an error telling me that the data types weren't compatible, or I can't convert John Smith into an integer, right? So with the concat function, it takes care of a lot of the work. And it just, I think it looks much prettier than having a whole bunch of casts and isnulls and whatever else you might have. So let's see. Oh, I've got an example, different example though. How it works as far as performance. So what I'm going to do is first, this table is not, oh, it's the big transaction history and big product. I was thinking the feature work tables are not that big, but the atom mechanics tables are. So this, at least the last time I did it, took 34 seconds. And I hate to keep talking through that, so I might just kill it here. I think it was comparable this morning. If I run it with Concat, last time I timed this, it took 31. Let's see if it takes 31. I'll let this one finish. But the other thing I found, because I did some other testing outside of this, and what I found was that the more cast, converts, is null you have, the longer the query takes to run. So like for this one, I'd have to have an is null on color. I'd have to have a cast on product ID. And the more of those you have, the longer it takes for the query to run. Where I found is if I could, if it made sense, and I don't have the rows coming, it took 40, so I didn't let the other one run. But in my testing, if I was able to use one concat for the expression, it typically scaled better than if I had lots of individual is nulls, coalesces, casts, whatever. It scaled better. So I would not be afraid to use this function either. Now, format is different. It's so handy. You know, oh, that ran pretty fast. But is that on? That it is on big, only 100 rows. That's why it ran fast. At only 100 rows, it ran pretty fast. I'm going to drop the clean buffers and go ahead and insert it with the convert. Convert is pretty nice. A lot of people don't like to use it because it's not ANSI standard. They like to use cast. The nice thing about convert, and this is something that's been around as long as I can remember, but the nice thing about convert is you have these different styles that you can add to format your dates different ways. So if you ever are curious about that, go out and look at the Microsoft documentation on cast and convert. And it'll show you what all of these little formats are. And I may not let that go just because it's taking so long. And I'm not going to run the next one. So when I tried to run previously, it took 34 seconds on a different day, not today, to run this. When I tried format, which is so easy to use, I just hate that it doesn't perform. It took over 2 minutes. So I would say, unless you're just working with a smallish amount of data, don't use format. I definitely use convert. And I would also use some of the others that I showed you. Concat, I don't have an IIF example. I would just use, instead of IIF, I would just use case, especially if it gets a little complex. So are there any questions at this point?
No, Kathy, none that I can see.
Okay. So this is my favorite, one of my favorite photos of all time. This is one that I took on a black sand beach in Hawaii. And it was like a dream of mine to take my whole family, my kids, their kids, my husband, he got to come along too, on a trip to Hawaii and renew our wedding vows on a black sand beach using the vows, the Klingon vows from Dax and Worf. We did not get attacked with the bat'leth at the end, but we did use the actual vows, and it just was really cool. So that's why I'm like, I got to have something about an island so I can show this cool picture. And these are the turtles that had crawled while we were there, crawled up out because it was getting towards evening, and they were crawling up out of the water. I guess at night they would sit there. I'm not sure. We left before. When we left, they were still there. So let's take a look at islands and gaps. And this one's a little different. I did not try to find the old way to do it. I guess I should do that. But it's kind of, this problem is kind of interesting to me because years ago when I was writing a book, I don't know if it was on a beginning T-SQL book back in the day or my first windowing function book, but I heard about islands and gaps, and I know I solved problems like that in some computer science classes that I took, but not with T-SQL, with C++. So I purposely did not go and look for any solutions. I tried to figure it out myself. And then later I found out that some other people had done it the same way I did. Others had found it a different way. So let's start with, well, first of all, what are islands and gaps? Islands are contiguous set, numbers or dates. I'm just going to stick with numbers here because we can eliminate one calculation of dealing with the dates. So contiguous numbers, and a gap is going to be where numbers are skipped, okay? And if I look at the data, I find that the first island is 1 to 5. Pull that up so we can see. So the first island is 1 to 5. The next island is 8 to 11. There's an island 13, and then the final island is 15, 16, 17. So those are my islands. How can I find those with a query? What I do often is I just got in the habit of throwing a row number into the query to kind of look for patterns, either row number or rank, or just to see if I can find some patterns. So that was the first thing I did. And I noticed something very interesting. I noticed that the row number and the number were the same for the first island. But then when I got to the second island, the row number was 2 different. And then the third island, it was 3 different. And then the fourth island, it was 4 different. And I'm like, oh, what if I subtract those? So the next thing I did was subtract the row number from the number. So I got this difference group. So I used a window function that's been around since 2005 to group basically these numbers into the islands. So I have island 0, I have island 2, island 3, and island 4. At this point, I can just use an aggregate function to come up with the min and max. Okay, so I can find the minimum in the group is my start of my island, and the maximum is the end of my island. So now I get back my islands. Okay, so wasn't that difficult once I saw that pattern. What about gaps? So the gaps, if I pull that up again so we can look at it. At the end of the first island, the next number is 6. That's the beginning of my gap. The end of my gap is 7. We've got a gap that's 12. We've got a gap that's 14. So I started with my island. I took my query. So I had first, I liked, like for things like this, I like taking the pieces and throwing them into common table expressions when they build on each other. I guess I didn't mention that. Did I do that? Yeah, I took this query without the order by and threw it into a common table expression. Okay, so now I've got this part in the outer query. I took that and threw it into a common table expression. Then I got to use, so then looking at this, I can say, well, let's say to figure this one out. If I have this island, the end of my gap is the row before in the data. And here, it's the row later, okay? Or you could just, have a subtraction if you want. So what I did here was use lag to find the previous, let's see how that turned out. I used lag to find the start of the group and subtracted one from the row to find the end of it. It probably took me a while to figure this out. I'm looking at it now and like, how did I do that? So there we go. Now, if I want to eliminate this row, because that's not really a gap, a gap, what I could do is filter it, but I can't filter on lag. I guess I could have filtered on this expression. But what I ended up doing is throwing this part into the common table expression and then just did an is not null in the outside. So you cannot filter directly on the result of a window function. You're always going to have to separate it out in some way, be that a common table expression, subquery, temp table, whatever. So that's how I solved that. And and I think what I need to do is the next time I give this, I ought to go ahead and see if I can figure it out pre-2012, because I never have done that. So I think I should do it. So are there any questions?
None, Kathy, nothing that I can see.
Not even any questions about Hawaii. Oh.
That's beautiful, by the way. I love that
Thank
picture.
you. Yeah, and even the smallest who went along, he was not quite 3. Still talks about it. Still talks about the trip.
I remember you're saying your granddaughter asked if you were married after that.
Yeah, so Dennis and I renewed our vows, and our daughter was the I guess in the original Star Trek episode, it was the woman of the house. So our daughter was the woman of the house and led the ceremony. And as we're walking, after that, we walked to the car, and my granddaughter was 6 at the time, I think, maybe 5 or 6. And she said, "Grandma, are you and Grandpa going to have kids now?" So I thought that was hilarious. And I laughed, and at the time she got really mad at me that I laughed at her, but I told her that the other day. She didn't remember it. She's 9 now, and she thought that was pretty funny too. So, which is good. So intelligent query processing. I probably have a couple of, it's like I've got, I'm trying to see what's coming up next in my slides. They're not automatically showing me. Okay, intelligent query processing. I feel like it is a cause for celebration because there are so many anti-patterns that don't perform well, and in some things that just there's no way around them. And Microsoft is making changes to the optimizer to take care of some of these issues, in many cases without changing code. It's not an excuse to write bad code, but it is really great that they're taking care of some of these. So if you go out to the documentation about it, you'll see this graphic. Some of these optimizations have happened in 2017, some in 2019. If you see the word batch involved at all, like right here, and this whole section, even though this says row mode, and this one here, they are all Enterprise Edition only. So you've got to be careful. I am really hoping that they bring these down to Standard Edition someday. And Microsoft does have a history of bringing some features down. So let's keep our fingers crossed. So I have got I started probably 5 minutes late. So I probably have another 5 minutes, if not 10. So I'm going to go ahead and show you some of these. And I've done an entire session just on these features. So the first one I want to show you, I love, I'm thinking I'm giving it away right there. I love so much execution plans on. I love it so much. But
so Kathy, there was a question.
Okay.
Person was asking, are there any windowing functions that are not there but we'd like to have?
There are. Itzhak Ben-Gun is really the one to ask about that because he has been pestering Microsoft about some of them. Some of them have to do with periods of time where you can look at the data. Like if you wanted to say, I wanted to get year over year or month over month, which you can do with the running totals and averages and things like that. However, if there's any missing, everything gets messed up. So I know there's some of that. So the range, so I talked about the framing, rows between unbounded preceding and current row. There's also range between unbounded preceding and current row that's not fully, we don't have the full functionality. That also has to do with time periods. So I know that. I would say that Itzhak Ben-Gun probably has a whole bunch of requests, those are comments into Microsoft about different things because he's always studying the future where I'm usually not. I'm usually just paying attention to what we have now. I'm going to go ahead and go through this one, which is one of the intelligent query processing features. And I'm going to create a stored procedure just to make sure I always get exactly the plan, because I hate to mess up a demo because I've grabbed an extra space or something. And I'm going to set the compatibility level down to 2016 and free the cache. And I got two calls to the stored procedure. And I'm just going to run them one at a time so we can look at them a little easier. The first one returns 206 rows. And another thing I didn't think to tell you on this, a column store index needs to be part of the query. And that's another thing that I hope Microsoft changes. I have more wishes about the intelligent query processing than I do about window functions for some reason. But if they could expand this, oh my gosh, it would just be unbelievable. A lot of consultants may have to work less hours. But anyway, so we've got 206 rows. And if I look at the execution plan, I see that it has a clustered index scan, which makes sense because of, there is a where clause, but it's a pretty good number of rows. So it chose to use a clustered index scan, and then it filtered here. And then it's got a hash match. It does have a missing index that it recommends, but we're not going to look at that for now, or actually at all. I'm also going to run this example where it only returns 5 rows. If I take a look at the execution plan, you can bet that it's using the identical execution plan, even though it might not make sense for that small number of rows. Okay, parameter sniffing, right? And there's a lot of other things that could happen. So I'm going to go ahead and free the cache again. Now, it might be that your server was restarted at night. It might be that this particular plan fell out of cache because it hadn't been used. There might be a lot of reasons, a few reasons that it's no longer in cache. So if I run this one first, the small number of rows first, I've got a different plan. So for a small number of rows, a nested loop would be better. We still have the clustered index scan. The plan does look quite a bit different. When I run the large number of rows, guess what? I also have a nested loop, which is obviously not the right plan for that many rows. And this is something that happens. Every place I've done consulting has had a lot of issues like this. So what I'm going to do to solve this problem, what I could do, well, a lot of times I see lookup queries, key lookups, which this doesn't solve, by the way, which is another one of my wish lists. Thing on my wish list, I would like them to expand it to solve key lookups, to where one number of rows, a key lookup's okay, but another number of rows, the clustered index scan would be better. All right, so I'm going to run these. And remember, for the 78, it was the nested loop that was better. When I look at the execution plan, I'm like, what in the world is going on here? It looks like I'm calling I'm scanning the table twice. And I don't see a nested join. I see this thing called adaptive join. So that's the new feature where SQL Server saves basically like two plans in one, and it can switch back and forth depending on the number of rows going through. So for example, if I look down here, I can see that clustered index, I see a clustered index seek going right to the join. And I see this other one that was part of the other plan, but it's got 0 rows going through it. And if I hover over this, and I'm going to try zooming in, didn't work. Try it again. Worked that time. Take a look at this. The physical operation is an adaptive join. The actual join, the estimated type was nested loop. The actual type was a nested loop. So this is giving you the correct plan for that number of rows. Let's go back and run this one. This is the one that needs the hash match. Again, the plan looks the same, except that you can see that we've got rows running through this path. Okay, so the rows are running through this other path. And when I hover over the adaptive join, I see that it estimated a nested loop. It estimated that because that was the first one that ran. However, it didn't use a nested loop. It used a hash match. And I think this is wonderful. And Microsoft, if you're listening, number one, bring this down to standard edition. Number two, let's have this for row mode, not just column store. I want to use this for my key lookups, or any other things that I can't even think of right now. I want to be able to use this anytime that there are 2 or even 3 possible plans that are good and dependent on the number of rows. I want this. And I think that probably a lot of you would agree with me if you came into some of these issues. So I'm going to bring up a couple more slides. My slides and code are here out on GitHub. So if you want to screenshot that really quickly. And I have a bunch of resources where I talk, here's some, the articles on the speed freakery that I wrote many years ago. End of month, other articles that I wrote many years ago that talks about breaking problems down. It's not always great to just use one gigantic crazy query. Sometimes you need to break things down. Intelligent query processing, another introduction to T-SQL window functions. And I was interviewed on Channel 9 about scalar UDF performance, which I didn't cover. So are there any additional questions before I sign off?
None. There is somebody who thinks it was a great presentation, and so
Thank
do
you.
I. So
Thank you.
to pass that on.
Thank you. This is
Anybody
probably my,
else?
pardon me?
Yeah, there are two people saying that it was really great.
Thank you. This is probably my most fun presentation to give. So,
All good things, Kathy, just compliments. Yeah.
Awesome. Okay.
One person wants your contact info. I think that was on the slide, right?
If it's not, I can put it up there. Let's see.
Okay.
Actually, it wasn't. So let me add it really quick. And oops, I don't know how to spell my name.
She's Kathy with an I, by the way, people.
Yeah.
Yeah.
As long as they call me Kathy and not a different name, I'm cool. But if they want to call me Kelly, I get called Kelly a lot, which is also cool. Or Cat. Oh, that's it. Oh, you can't see the G. That's a G right there, hiding behind the plural site thingy. Oops. I must have an automatic. I have an automatic forward on that slide. I'll have to take a look at it because it jumps ahead. So there's my email address at Redgate. Yep, it just went by itself again.
One person said, I first taught myself SQL from your beginning T-SQL 2008 book. Thank you so much for that. Yep.
Yay. That's also was a labor of love for me. It was so happy that it has made a difference in a lot of people's lives.
So if any of you listening, if you ever want to write for Simple Talk, I know there are a lot of smart people. I highly recommend it. And Kathy really, she's extremely patient, and she really teaches you how to write a good tech article, not just about the stuff. I mean, she has the patience of a saint there. Really.
Thank you. Thank you. Yeah, and it's it's a fun job, and I get to work with so many people in the community. And if you're interested in writing, especially if you've already been like writing some blogs or whatever, this might be the next step for you.
Right. And it sticks around a whole lot longer than writing any printed material. It pays really decent. So recommend it in every way.
Absolutely. If you do reach out to me, just tell me that you heard about it at this session. So I get a lot of really junky requests where there's just sites that are wanting to do backlinks and stuff. So if I know it's really a real person that is part of the community, we definitely want to talk to you.
Yep.
So, but I get a lot of spam. So let me know where you heard about it.
All right.
Okay, so I guess I can stop sharing. Everybody should have gotten, I don't even see where to stop sharing. Let's see, I guess maybe here.
Yep. Thank you, everyone.
Yeah, thanks a lot. It was a lot of fun.
Yep. I don't know how to close this down, but we're good. Bye, Kathy. Take care, and thanks for the long day.
Yeah, we've been working together most of the day today.
Right.
Bye.
Sleep well. Bye.
You too.